Black holes are some of the strangest and most fascinating objects in space. These mysterious entities are incredibly dense, with a gravitational pull so strong that not even light can escape. In our own Milky Way galaxy, there could be over 100 million black holes. Detecting them is no easy task, though. The heart of our galaxy harbors a supermassive black hole named Sagittarius A star. This colossal entity is about 4 million times the mass of our Sun and sits roughly 26,000 light-years away from Earth. We can't see black holes directly because they trap light within them. However, their presence is revealed through interactions with nearby matter. When a black hole pulls in material from a neighboring star, it forms an accretion disk. This disk heats up and emits X-rays, which we can detect with our telescopes. Let's delve into the world of black holes through the insights of some of the most renowned experts and researchers. So let's embark on this journey to understand what makes black holes such captivating objects in our universe.
Describing very briefly what a black hole looks like. So, a black hole, what do you see from the outside? Well, there's an event horizon surrounding the black hole. In some sense, it defines the boundary between the external universe and the interior of the black hole. And if you go across the boundary into the interior of this sphere, then even if you can travel as fast as the speed of light, you can't escape the gravitational pull of the black hole. But another description of the event horizon, which confused people all the way through the history of black hole research actually, was the idea that the event horizon, when viewed from the outside, is a place in space where time stops. Now that's a direct prediction of Einstein's theory of relativity from the external perspective. There is a central problem though, which is still not solved, which is what lies at the center of a black hole.
Many people have in mind that black holes sort of reach out and grab everything in.
Yeah.
But a black hole of mass m, a black hole whose mass is the same as the sun, has the same gravitational pull as the sun. It's not, it doesn't pull any harder than the sun. It's just that you can get closer to it because it's so small, and therefore you can experience the gravity more strongly. But, you know, a brick of mass m and a black hole of mass m, they exert the same gravitational pull.
Okay, so we have this misconception that black holes are always these supermassive objects that have incredible amounts of gravity, and they're sucking in planets and stars and churning them out. Because we're thinking of massive black holes, like the supermassive black holes are at the center of the galaxy, which is like, what, 1/2 of 1% of the mass of the galaxy?
Well, let's see. So if our galaxy has, say, 100 billion suns, you know, and that guy is about 4 million times the mass of the sun, you're talking about, you know, 1,000th or something of that sort.
Isn't that crazy when you say that, 100 billion suns, and you have to wrap your head around the idea of 100 billion stars, and that's just our little puny little galaxy.
Well, that's a thing. And
Isn't that crazy?
There are at least 100 billion galaxies.
At least.
And this is just in the observable universe. I mean, do you know, if you take your thumb and you put your thumb on a nice clear night and you block out a thumbnail worth of the sky, you're blocking out about 10 million galaxies.
You know, today modern science is proving to you beyond any doubt that the whole existence is coming from nothing and going back to nothingness. You know this? There was a time when modern science believed everything comes from something. You can neither destroy something nor create something. It can only be transformed from one state to another. You cannot destroy anything, nor can you create anything. That was the belief some time ago. But today, modern science is proving beyond any doubt that everything comes from nothingness and goes back to nothingness. A whole bunch of galaxies sometimes just collapse into themselves and become nothing, you know. There's something called as black holes. Some of them explode into supernovas, but a lot of them just collapse into themselves and become nothing. So there was something and it became nothing. Similarly, there is nothingness and it becomes somethingness. Nothingness is the very basis of all that is something in the creation, please see. Only because there is a vast nothingness, somethingness has happened in the form of tiny galaxies. If you look up in the sky, Generally, the way your vision is made is, you think it's full of stars, but that's not the reality. The reality is there's a vast empty space, just tiny spots of stars. Isn't it? That's a reality. But because of the way your vision is made, because of a visual deception, it makes you feel as if the sky is full of stars. The sky is full of emptiness. Just a little bit of stars. Just a little bit of salt and pepper. Rest is all darkness and emptiness. So everything springs from that and goes back to that.
And now you can hear the sounds of a black hole.